this series of webinars, which we call the ESICs, Environmental Sustainability and International Cooperation. So I'm Guido Zolezzi, I'm professor at the University of Trento, and I have the pleasure of being the moderator for this first seminar, this first webinar of the ESIC series. So I will take a few minutes today at the beginning to introduce the series of seminars and to explain briefly why we decided to host these seminars, and together with some practical information. So first of all, this series of seminars are organized by a group, are mainly organized by a group of young researchers and students, together with some teachers in the Department of Civil, Environmental and Mechanical Engineering in the University of Trento and in the Center for Agriculture, Food, Environment of the University of Trento. We are part of a team, of a group that is interested in addressing, studying, investigating, and also in the educational part of what relates engineering and development. In the multiple, let's say, dimensions of development, especially in relation to sustainable development, human development. And as we are mainly working in environmental issues, our part of engineering is mainly environmental engineering. And this team has a kind of umbrella, which is the UNESCO chair. It's a brand that the UNESCO decided to establish with our university 10 years ago. It's called UNESCO Chair in Engineering for Human and Sustainable Development. And in the communications related to the webinar, you have a link to the webpage, so you can, if anyone is interested to know more about our activities, there you can find them. And probably several of you at least have seen also the social media networks of the chair. But yeah, the core of our activity is putting together environmental engineering and development. Probably the main activity, or let's say the activity that is at the core of our teaching in a university, is within a master course in environmental engineering. And it consists of several elective courses that form together a track, an eligible track in what we call environmental sustainability and international cooperation. So the name of this webinar series is the same name that this set of courses within the master degree in environmental engineering will get starting from the next year. So that's why we kept the same focus, because this is our focus basically. So why these webinars? We wanted to, I mean, in these years we have worked quite extensively with many partners in different projects on many different aspects of environmental sustainability, and many often in connection with international cooperation contexts. So we wanted to create a forum, to create ideally a physical place, but this year this is not possible. but at least a virtual place in which to promote exchange of ideas, of challenges, of critical issues, and of possible way forwards on different aspects of this, let's say, nexus between environmental sustainability and international cooperation. So we'll try in these seminars to be at the interface between these two dimensions. So environmental sustainability is a huge dimension, can mean many things, and international cooperation as well. What we seek to address in these webinars is a dialogue, a debate on issues that are at the intersection between the two. And this is our main focus. So I'll try to share the screen just to comment briefly the program of the seminars. Can you see a PDF with the...
Yes.
Yes, we do.
Thank you. So I will not go in the detail of every seminar and talk that is planned, but we try to cover several topics within this interface. Today we will start with green energies, and we have 3 very distinguished guests that who I will introduce in a short while. And then we'll move to water resources in different, let's say, viewpoints, from wash to resources management at larger scale, to the nexus between water, energy, and food, hazard and geological risks, and agriculture. The choice of the speakers, which you see are a mix of national, international, let's say Italian and non-Italian speakers, but I would say all of them working in international context. Some Italian names you see here are working outside Italy since many years. And we try to create a mix between researchers and practitioners. So this is not, strictly speaking, a series of research seminars, scientific research, and not strictly speaking a series of seminars with mainly and only or exclusively practical implication. We thought that it was very important to have a mixed set of voices from those who develop scientific research on this topic, which clearly is very much applied research, because they seek to diagnose issues and challenges emerging from the field and to propose solutions in the field, but also to mix with the point of view of practitioners, for those who work in international cooperation and have practical experience from the ground. And we hope that this will be a good condition to keep the webinars lively, together, of course, with your participation, with the participation of you all. We are very happy of the very strong response that we got, the strong interest to the seminar. I think we have more than 70 people who are, let's say, registered for the seminars. And I will conclude just with a quick practical note, so I can start, I can stop sharing. First practical note, please keep always an eye on the calendar, because some dates, especially in May, could change. But we will, of course, inform you. All people who register will be informed about changes. So I'll move to other practical issues. So some of you are students from the University of Trento, and some of you are students from DICAM and from environmental engineering. So this series of seminars has been recognized by DICAM as a seminar as a credit type F course, 1 credit, and the credit will be obtained through attendance to 75% of the seminars. Of course, we advise you to attend all the seminars because they're very nice and stimulating, I think. And then there will be a final test. It's already, I think, written on the communication and on the website how the test will be, but maybe we can set a target moment during in the next meetings or in the next weeks, just with a group of sorry, with the students who will take the test, not to let's say take too much time now. Okay.
Sorry, I have a question about the credits.
Yes.
It's possible for a PhD student have type B credits without the exam?
I think so. I think in the end it's up to the PhD council to approve it, or simply the director. But yes, I think that. Are you in C3A PhD in Agri-Food Environmental Sciences?
Yes, yes.
Yeah, I've seen the email, I think. Yeah, I think it should be possible. It's mainly on the side of the PhD program, but we can connect with the PhD secretary to communicate this.
Thank you.
Yeah, maybe if there is any quick question now about, I mean, some practical and very short question now. Okay, all the events will be registered. And they will be available, I think, on the YouTube channel of the department, but this is still to be activated, I think. So, but anyway, the recordings of the seminars will be available. So before introducing the speakers, I really would like to thank very, very much Livia, Marta, Nicola, Matteo, Marco, Luigi, and Massimo, because this group has been proposing the seminars, organizing the seminars, keeping the contact with the speakers, designing it, and so really you did 99% of the job. So I think I really want to thank so much all the group. I'll now move, if I don't forget anything very, very important to say, I'll just move quickly to present the speakers from today. So they're all engineers. We have Tobias Diana. He will talk about the BioHeat system. Tobias is CEO of a company that he started, Biologic Systems. And it's quite interesting that Tobias and then Andrea Bello and Jacopo Barbieri, the other two speakers, all of them have an interesting mix in their CV, in their activities, educational and professional activities, between the private sector, international cooperation, and of course, their background in engineering, from environmental engineering, energy engineering, and yeah, mainly these two. Andrea Bello has been a student also like Tobias, though in energy engineering at the University of Trento. Tobias did his bachelor in Austria. And Andrea Bello participated in an honors program, which is called Talete, promoted by different departments of the University of Trento, DICAM, Sociology, International Studies, that focus on soft skills and foresees let's say, a thesis, a master thesis, and extra training in international cooperation context. And now he's working for an important hydropower company in the region of Trentino after his experience in international cooperation in Tanzania. And Jacopo, well, we met several years ago. He studied in the Polytechnic of Milan. He did his PhD, I think, in the main research group in Italy, one of the most important research group at the international level, working on energy and sustainable development. And so we met when Jacopo was doing his PhD, and now after a postdoc, he moved to Uganda, and he's now the technical director of technical manager at St. Mary Lakor Hospital in Uganda, in Gulu, Uganda. And during his PhD, he developed a strong component in scientific research. So I hope, starting from this seminar, we have achieved this mix between research and field activity that we aim to have in all the talks. Okay. If I have not forgotten anything, I'm asking the team, but you're not saying anything, so it's probably okay. I'll leave the floor to Tobias, Diana, for your talk on the BioHeat system. Thank you, Tobias, very much for being with us today.
Thank you very much. It's a pleasure for me to be here today. And now I just try to share my screen. It should work now. So first of all, thank you for the invitation. I'm talking to you today, one side as a CEO of Biologic Systems, but also as the professor already told you, I had some experience in international cooperation, in development activities in Kenya. I need to make at this point a small correction of what the professor told. I made the bachelor in ASA, but I was also a student in Trento. I made my master's degree in energy engineering there. And yeah, it doesn't matter. It was written not well in the biodata. Anyway, now just a second. I put the big screen. Well, okay. So I will start now to talk to you firstly some little introduction about myself and also about the way of how it came to the BioHeat system, because I think it's important. You are students of engineering and my focus will be today on the BioHeat system, but also on the world of circular economy and some challenges I have experienced by my own on biologic systems, which are probably, in my opinion, the future challenges of engineers. But let's just start. So my name is Tobias Diana again, and I have started to work and to think about waste since my very childhood. Maybe the passion came also because of my background. I have some relatives in the Terra di Fuochi, so since my childhood, I was seeing this enormous waste problem around Italy, but later also around the world. So I started to make my career to get in some position to change something in that field. And after my bachelor degree, I started an experience in Kenya. I was working for a local NGO, and we tried to build up waste management system for so-called Congovea market. It is an enormous market in Mombasa, where it comes all vegetables and food from almost the whole Eastern Africa reaches that point because there is a big port and a big rail station, and from there it comes to the country. So in this market we had a situation of about 90 tons biological waste every day, and we tried to develop a sustainable solution. It's very important also, I will use many times the word sustainability today, and just to make sure that the definition is the correct one, in my opinion, and that's the way how I understand it today, the sustainability must be on 3 pillars. So that means economic, ecological, social, and since we are Italian, we could also add some kind of aesthetics. But this is very important because many times today people understand or associate sustainability with a strictly ecologic way of things, but it isn't. And it's very important that a technology has all 3 points. Anyway, why it's important, this experience in Kenya? There I found and I discovered the possibility to extract heat from compost. That's actually my daily bread now, making plans for compost heat recovery. But still, that was not a factor, and the thing which let me start this adventure of creating biologic system and working on this technology. This was the main part. So this is a landfill still in Mombasa, and this landfill was direct on the ocean. So every day tons of waste fall into in the Indian Ocean, and I found there many European waste, so labeled or computers with some British companies, and so. And this thing let me think a lot about the whole thing, what I'm doing there, and so on. And I decided to go back. So I finished there my proposal. I lived that in that company, and they were proposing it to some politicians and so on. And I came back. So I saw such a situation. This is in South Tyrol, but it could be also in Trentino. There are very similar situations. And here we see in this imagine these prunings. Probably all of you know prunings. This was the starting point. So I saw these pruning residues, which today are just destroyed between the fields, and the biomass is not used. So actually, if you know something about agriculture, it can also, and it causes some problems, causes a lot of workload. And I started to think, okay, we have so many hotels here, and there is actually this problem of getting rid of these biomasses. So I recalled this, the knowledge that we can extract heat from compost. So I studied the problematic. So the problematic is in South Europe, but also in Trentino and Northern Italy. It's first of all, we need heat. So electricity is not so much a problem as probably we hear later. The Ingegneria Dolomiti has a lot of hydropower plants. So the electricity is somehow covered in a sustainable way and in a renewable way. And as I already said, the problem of get rid the wood waste, and it's not only pruning residues, there are also rootstocks, etc. when changing the cultures, and sustainability, the word of the millennium, hopefully. It's getting important. It's important for future generations. It's important for the world of business, for politicians, and so on. And I tried to develop such a solution. What are the problems today? So the problems today are that at one point we use fossil fuels, which are actually expensive, if not some mechanism are to make them cheaper. And to get rid of the wood, it's extremely work intensive, and at the same time, it's an inefficient treatment because it's just destroying it to not see the problem, actually, what is done mainly today. So now again, the principle of sustainability, because this was kind of the way how I was thinking to find a solution for the problem I have mentioned before. And this is what came out. So the BioHeat system consists in a solution which takes woody biomasses for now, and hopefully in the future also other kind of organic materials, and we compost that during a yearly cycle, and during this period we extract heat, mainly constant, so it doesn't be influenced by sun available, by the seasons and so on. And after 1 year, the biomass is composted. We have introduced the heat for the whole year into a building, in a swimming pool, or in whatever heat is required, and it remains this compost. The compost, we increase the we have some strategies to increase the quality of the compost according to the needs of the agriculture, and we have then some specialized machines with which we bring back the compost out in the fields. So our solution, we saw and we found out that we need to offer a complete solution. Why? Because the farmer does not have machines, he don't have the time, he don't want to do some things. And this is very important. So we developed the BioHeat system as a turnkey solution. So we take care of the whole thing. And these are actually very important facts also by introducing new technology, because it would be useless to have the best bioreactor, which is working perfectly, but if the customer doesn't has the possibility to collect efficiently the biomass, he will not use the bioreactor. So this is the reason why we developed this whole solution and this turnkey, and we are seeing now it was a good idea because the feedbacks are very good. Let's start the woody residue. So it's a very important factor is the collection, because when we are thinking about green energies, we would think about the price, about the efficiency, about so thermal efficiency in that case. But in such a solution as we are talking now, compost heat, it's not the same as burning this material. It's obvious. If we burn, we have 100%. If we make compost, we reach something about 50% of the total potential energy in the biomass. But it's still sustainable, even from economical point of view, but also ecological point of view, because we don't need to add energy or afford to collect, because anyway there are some jobs to do. For example, we use this tractor with a mulching machine, which is actually the same as would be used normally while we are collecting it. So usually they have the mulching machine, they're just destroying the material. This special machine is doing the same but collecting. So we give some more advantages, not only energetic advantages, we give in the user some agricultural advantages, some waste management treatment advantages, and also some energetic advantage. So this allows to have a technology which actually just by thinking of energy would be less efficient from compared to other technology, but the whole cycle makes it more efficient than for example solar thermal collector. This is a very important thing for future solution technologies from my point of view, because we have now a lot of technologies possibilities. I mean, we are very good engineers, we have very good engineers in the world, but now we need engineers which connect the different technology, make them sustainable and make them interesting for the wide population. So for as much person as possible, and therefore it needs to be sustainable economically, ecologically, social, and aesthetically. And just a little bit why I'm adding this aesthetically, because compost heat is not something which I have invented or discovered or something. It's actually something which was used 2000 years ago by Japanese, and later in the 70s they started to actually use it for heating buildings. And but these plants which were made there, they have, first of all, they are extremely inefficient, but they are extremely unaesthetic. So no one would like to have next to his house such a plant, because it's just a big heap of compost. And if you don't know what it is, you might think that it's a big heap of some word with S. So the second aspect of the technology of the solution is the bioreactor. The bioreactor, which we see here, it's a technology where it's the composting process is done. So as you can maybe see, it is not a simple compost heat. There are inside some technology. We have heat exchanger, as we see here. Later, there are some condenser plates. We have a controlled aeration, we have controlled humidification, and so on. So this technology makes once the extrapolation of heat from a compost process efficient, it makes possible to make it simple. So to do that with the correct machines, it is easy. If we see the solution from the 70s, I have also built one in that way. We were 10 persons for one day just to fill it, and it's an enormous act of work. And later the compost is brought back to the field. That's something not new, it's something it's used since many years. So it's, let's try some numbers. Maybe you are mainly technicians, so I will skip this and go to this slide where there are some more numbers. We engineers, we like numbers. So this is the potential in Europe. I don't want to focus on monetary potential, but money is also a way of energy and things to it describes very well the thing. But anyway, if you're thinking on an energetic point of view, this technology allows to transform the whole biomasses, which, sorry, I need to go back, I don't remember. Yeah, about 30 million tons in Europe in dry matter. So into 91,000 gigawatt hours each year. So it's a lot of methane gas, which we need less to import. At the same time, it produces 16,000 tons of compost. A million, sorry, here is a mistake, million tons. And there is some big advantage in waste management, or some advantage in waste management savings. So that means today you need to take, for example, rootstocks are taken from the field and are brought approximately 15 to 20 kilometers to a centralized composting plant or a communal composting plant where it is treated. So this is extremely inefficient. At the same time, composting is one, saving CO2 emission because we are not burning fossil fuels, but it's one of the major possibility to capture CO2. So compost is something which is fixing CO2 because the biomass absorbs CO2 during his life day. And if it will be burned, we have a zero balance. In the moment where we are able to put this carbon back to the soil, it is fixed. And maybe in a few million years or a few 100 million years, it will be petroleum or even a diamond. We wait still more time. the solution compared to other green energies or in general energy, it's cheaper. Why it's cheaper? As I was saying before, we don't have any cost for the resource, and we have at the same time agriculture advantages. So for getting wheat rootstock, the customer saves money, and this makes it possible to the overall cost of kilowatt hours. It's less compared other technologies. And this is the thing I was saying. No? Today we need to combine things, because all the simple things we have discovered. We have good way, maybe there are some potential still to be better, but by combining, it's still a big gain. We can reach big gains with not so much effort, because we now sell, or we make plants since actually 1 year, but still we have reached an efficiency where we are cheaper compared to other plants. So since 1 year as a company, we have made many, so the BioHeat started the development of the BioHeat in 2015. So there's some know-how and some work behind, but since 1 year we are offering them on kind of market. So summing up, the solution allows to collect and use biomasses efficiently, which otherwise would be kind of wasted or not used, because the definition of waste is something which has no value anymore. And we transform something which is a waste in a resource, because before there were no value, now it has a value because we can use it for heating the building. We have no problems of humidity and so on. So the technology is user-friendly, so the customer can have it even if he don't knows anything about composting, and so it is also profitable for them. One example, this is a plant, the first plant we built, or it went in operation one year ago, and we used 7.7 hectares of agricultural pruning residues, 5 hectares from apple orchards and 2.7 from wine orchards. We put it in this plant, and after 1 week it started to produce the heat. And as we see here, we have the temperatures are always above 50 degrees. If someone has experience with compost, you might say how it is possible to have such a long thermophilic stage. This is so the explanation we have found until now, and it's actually the correct answer. It's we have woody residues. Wood is very hard. It has a lot of lignin, which is protecting the cellulose, and to break that structure, bacteria needs a lot of time and a lot of it's not simple. That's the reason why this process is so long. If we think of grass is composted in about 2 months, because there is a very it's not hard it's not a hard structure, so it's composted fast.
Sorry, Tobias, you have 2 more minutes.
And I don't need any more. I mean.
Okay, great.
Thank you very much for attention. If there are questions, and yeah, I'm the opinion you can never save enough CO2, money, time, workload, and let's do it for the future. Thank you. If there are questions, you can also take the number, call me, or write an email, or maybe later we have time for it.
Yeah. So thank you very much, Tobias. That was really an interesting topic you proposed. It was very interesting to hear how from how your experience in international cooperation then triggered, in a way, some of your reflections, ideas, and activity afterwards.
Thank you.
I think, so So we plan to move to the next speaker immediately, and then we'll have a question and answer time, discussion time after the three talks. So I'd like to introduce Andrea Bello. Andrea Bello has got his master's degree in energy engineering at the University of Trento, had this experience in Tanzania in international cooperation, and is now working for one of the most important hydropower companies in our region. He will speak about quality of energy access, and he will be the parallel between this common need in developing countries and in the EU energy transition. So the floor is yours, Andrea. Thank you.
Thank you, Professor Zoleddi. So now I will share the screen. Okay, please tell me if you see something.
Yes.
Yes.
I can see it.
Great. So, okay, so the quality of energy access, we will see the common need in developing countries and the European energy transition. So, okay, first of all, why energy access? Why do we need it? So it is recognized by the almost totality of the International Cooperation Agency that energy access is crucial in achieving a wide range of advancement in all society sectors, from food security. We also have here cited the water, food, energy nexus, which will be the focus of one upcoming seminar. But also we have clean water, sanitation, hygiene, and also education, gender equality, but also, of course, poverty reduction. So really, it is also inserted in the 2030 Agenda for Sustainable Development of the UNDP. It has its own goal, number 7. Okay, but how can we bring the electricity access to the populations? So it is important to note that as of now, 800 million people lack an energy access, which is really a high number. It is almost 1 out of 9 people in the world. Of course, these people lives especially in rural areas of developing countries. So regarding the electricity access, the best option is to, of course, connect people to the national grid. But especially in rural areas of developing countries, this is really hard because maybe we have long distances and also orographic obstacles. And so the building of long transmission lines is expensive and slow. So another option is the using off-grid systems. Off-grid systems are like small grids with their own generator, serving a local, for example, a local area. They are defined as having a sub-regional scale. They are, of course, less expensive and require less time to build. You don't have the need of building long transmission lines connecting these areas to the maybe centralized grid. Yeah, I written islands in the dark because when you have so these large areas without access to electricity, you can see maybe these like small islands of light in the dark, because when you have off-grid systems, you can bring like spots of electricity. Anyway, when and if in the future the centralized national grid reaches that area, you can of course connect these off-grid systems to the central grid, so they can serve like bricks to build the grid of tomorrow also. By definition, they use small scale generators. This is a trend which is present also in developed countries, which is the distributed generation, but we will see maybe later. So I would like to jump directly to a real energy access project in a developing country, which is the access to electricity energy to the populations of the Bello district, Tanzania. This was the project I worked for some months. It was developed by the Italian NGO ACRA together with the Italian Agency for International Cooperation. It was also financed by the European Union and other minor partners. So the context is one of the poorest economies in the world, the United Republic of Tanzania. The project location is here, where you see the pin. As you can see, it is on the border of Lake Nyasa in the region of the Southern Highlands. So it was an integrated rural development. What does it mean? It means that it sees the electrification as a driver for socioeconomic development. So how is this achieved? This is achieved because, let's take an example. One of the activities was the reforestation. So in that area, still local farmers use unsustainable agricultural practices like the cut and burn practices. And so the project trained them to use some more sustainable practices. For example, they reforested a large area, which allowed to develop a commercial silviculture. In the meantime, the reforested area provided protection for the water sources and also for the soil, because the erosion of the soil ultimately creates a high level of sediment transport in the river, which ultimately can be a problem for the hydropower plant. So this was seen as a whole where many actions interact with each other. Then, of course, there was also a training and a microfinancing program for cooperatives and small enterprises with a focus on the women empowerment. And also all steps of the project were participated by the communities. We can see, okay, this is the project location. We can see, okay, just for curiosity, on the left, you have the border of the Southern Highlands. Then you have this large valley, which is the site of the project. And on the right, here you have the mountain range of the Livingstone Mountains. So we are between the two. We can see here also a map of the project. We have here the valley on the picture. And here we have the border of the Southern Highlands, while on this part, there is the mountain range of the Livingstone Mountains. This is the power plant. And you see also the Kizongo River and its tributaries. From the power plant, you see the red transmission lines bringing the electricity to the villages. You see also the position of the transformers for distribution. Okay, some numbers. The power plant is a run-of-the-river type. It has 300 kilowatt of installed power. You have here some numbers of the connected users. Beyond the number of families, I would like to underline that there is a significant number of hospitals and medical dispensaries, but also schools and other social services. And you can imagine how it's making a difference for example, hospitals to have electricity or not. Another thing which is really important is that all parts of this infrastructure, the electrification, are owned by the communities themselves. So during the construction, was participated, a group of people was trained by the project, and at the end they became and founded this social enterprise called Lumama, which acquired the ownership of all the infrastructure. So at the end, we have that the communities receive a service which is given by themselves, we can say, because everything is owned by the communities. And this is very important because if you want to have a project which is sustainable from also the social point of view, we must follow this participatory planning. But then okay, we can have some pictures of the infrastructures. This is the intake weir on the Kizongo River. And yeah, after this weir, the river follows a series of waterfalls, while the diverted water runs through the penstock down to the powerhouse. We can see it here. This is the powerhouse with the penstock. This is the inside of the powerhouse with the two horizontal axis Francis turbines. Something which is worth to note is that those environments are really tough, because we have also maybe situations which we are not, I speak as an engineer, we are not used to. So for example, we had the case of, for example, a very original turbine clogging due to a new type of bush banana seeds, which somehow and suddenly finished in the water of the Kisongo and was turbined, but it gets stuck. So this was just an example to stress the fact that developing countries need always adequate solutions. We cannot just transfer technology from maybe Italy to Tanzania, rural Tanzania. Yeah, at the end we have to redesign the intake rate. Okay, also this trend of distributed generation is present also in developed countries, but maybe I have time and I jump. We can see again the infrastructure. Okay, just for curiosity, we have the transmission lines coming to this distribution cabin, and then the transmission lines go ahead to bring the electricity to the villages. This is a distribution transformer where the transmission lines arrives, and from here the electricity is brought to the households. This is a road sign of Lumama, which is the electrical association made by peoples of the villages, which owns all the infrastructure. Okay, so in this way we are able to bring the electricity, but is it enough, or do we need something else? The really big problem is that the access itself is not enough. It must be an access of quality. For example, we see here this report from the World Bank, which shows that 15% of the annual sales of small businesses in Tanzania was lost due to power outages. It is really high. Also, other reports pin to 7% of the GDP lost to unreliable energy supply in sub-Saharan Africa. So really, for energy access to be really transformative, we need quality. But what do we mean with quality of energy access? So maybe is it useful to give a look to this multi-tier matrix designed by the World Bank for the quality of access to electricity supply. Okay, this is a multi-tier matrix where we have the tiers, which you can say are the levels of quality. So from this is the worst level, and the more you go right, you have a better level. It depends on various factors, as you can see. For example, the availability, because in many cases you can have an access to electricity which lasts for just a few hours in the evening, for example. So maybe you have 2 hours for the evening. Okay, you can charge your mobile phone, which is very important also in developing countries and rural areas. But you cannot for sure start a commercial activity using some sort of electrical equipment. So we need a high level, high tier access to electricity to start a series of improvements in the commercial tissue. But now let's go more bit in the detail of the technical question, because yeah, we are talking about the quality of the electricity, and from a technical point of view, the quality of the electricity is described by two main parameters: frequency and the voltage. We are talking, of course, of alternating current electricity grids, which is the electricity we everyone use. There is an entire branch of the electric engineering, which is grid dispatching, which we can say, focus on this topic, because the regulation of the electrical grid is a matter of equilibrium, but it has to be regulated continuously. Each instant, you need to apply a regulation to the grid because of these moments. You have, for example, the voltage. Okay, it is quite a matter of reactive power, but we won't go into detail of that because it is rather simple, the regulation. The real problem is the frequency, because the frequency depends on the balance of powers. So the power consumed must be equal to the power generated, always, in any moment. If you fail to maintain this equilibrium, even in for a short moment of time, the grid collapses. So this regulation, of course, there is also a market, and it is regulated by by governments, but it has to be done in continuous. So how can we perform this regulation? In off-grid systems, you are alone, and so you must regulate your own grid. In centralized system, you have a central control. Here in Italy, we have Terna, which is the transmission system operator of Italy. And of course, they have super technological control center, and actually they are doing really a great job. Okay, but from the point of view of the power plants, what kind of plant is able to perform this regulation? Sadly, the power plants which are able to do this are called dispatchable plant, and sadly, the fossil fuel power plants are the only one who are able to perform this regulation. Also, there are conventional hydropower plants and pumped, but they are not enough to do the job alone. Sadly, the mostly renewable energy sources that we know very well, sadly, are not able to do this job because, of course, if there is sun, wind, they can produce, otherwise not. Fossil fuel, sadly, are able to store the fuel, of course, and they can produce according to the needs of the grid. So this is the point. To allow an energy decarbonization of our system, we need to find an alternative way to provide these services instead of using fossil fuel power plants. We want to phase out those power plants, and we have also in Italy, for example, the phase out is in 2025, but we need to find alternatives. There is, of course, a lot of research on this topic. It is the general topic of energy transition, but still there is much to be done. So now I would like to present you this project on which I'm working, which is just one of the really many projects working on this topic. So it is the OSMOSE project. It is an European 2020 Horizon 2020 project. It aims to identify and develop the optimal mix of flexibilities for the European power system to enable the energy transition. It is composed by really many partners. It is a big project. We have also the TSOs, which is transmission system operators. They are the entity which owns and operate the national grid of countries. Of course, we have Italian one. And yeah, partners are from all around Europe. In Italy, there is okay, my company, Ingegneria, and also other companies. And yeah, the project also includes 4 large-scale demonstrators. Demonstrators are like big experiments where you test the finding of your research. So it is also interesting this practical aspect. The demonstrator where I'm working is this one, the package 6 demonstrator, which is a near real-time cross-border energy market. So this is this project tests the cross-border between Italy and Slovenia, and the purpose is to fully exploit the flexibilities. When we talk about flexibilities, we mean the ability to perform the regulations we were talking before. So this market through its characteristics of near real-time and cross-border, aims to release the energy constraints on already existing generation units, and also residual cross-border exchange capability, which is how much transmission capacity is left between the countries. The aim is to fully exploit what is already operational. So before building some new plants, we want to really extract everything we can from what is already operational. And also from Trentino, we have participation. Okay, so just in conclusion, I would like to underline that both in developing countries and developed countries, guaranteeing the quality of the electricity service will be the crucial issue for the building of the future energy sector. And because for both the human development of vulnerable communities in developing countries, but also for building a clear future for everyone, not only for developed countries. And okay, I finished my presentation. If you have questions or maybe later.
Thank you, Andrea. Thank you very much. I enjoyed a lot your talk, and especially how you highlighted this common point between different contexts. As I said, we plan to have a discussion after all the 3 talks, so I would like to welcome Jacopo Barbieri now. If we put together the initial letters of the talk of Jacopo, we have again ESIC, but sustainability and international cooperation, so it's perfectly in line with our series of webinars, and Jacopo will speak about the importance of a holistic approach. Thank you very much for being with us, Jacopo.
Yes, thank you, Guido, and the whole team for inviting me. I'm very happy to be here this evening. So let me share my screen. I also thank the previous panelists because they really helped me by introducing some important aspects that will be crucial also for my presentation. You should see my screen now. Okay. So the topic is very broad, and the idea was to create like a kind of cap for also the previous presentations. Of course, the matter is very broad. I cannot pretend to cover the whole thing only in a few minutes, but I will try to give some ideas that I hope will raise up your curiosity about the thing. So, energy, sustainability, and international cooperation. My presentation will be divided into 2 blocks. I will first introduce some fundamental concepts on the theoretical point of view, and I will try to apply them to a case, and specifically to the context of St. Mary Hospital at Ciò. So Andrea already introduced the importance of energy, so I think you have got it well. I don't want to focus much more on this. And I will go immediately to the important themes that I want to explore. Now, the first fundamental concept that I want to pass that somehow was given among the lines during the previous presentations is the importance of energy as, let's say, an instrumental right, as an instrument. So energy per se is not really needed for exploiting any human need, doesn't improve human dignity, doesn't, I mean, you cannot eat energy, you cannot drink energy, so it's not really something needed per se, but it is an instrument. So it is important to consider it as a right in terms of an instrument that provides you or provides any human being with the fundamental elements for the life and for well-being. A second concept that I want to introduce is the concept of appropriate technology. which is fundamental in a context of international cooperation. Now, what does mean, what is it? What is an appropriate technology? So technology is appropriate when it is designed taking into account environmental, ethical, cultural, social, political, and many other aspects from the local context, which basically means that technology is appropriate when it satisfies the needs of the user, and to do this, it needs to be developed in synergy, with a synergy between the technicians and the communities and the last and the utilizer. Which means that we need a very good understanding of the local context. To give you a better understanding of the concept, I will go with an anecdote that I know for sure it's fake. It's not really, it was not really like that, but it has circulated a lot over internet. And I think even if it is not really real, gives a good example of what of the concept. So it was narrated that in the 60s, of course, there was a big competition between USA and Russia about space exploration. And so the USA, I mean, the American decided to invest $1 million to create a pen that could work in the absence of gravity, because normally pen cannot write in absence of gravity. And so they had a big team of scientists that were studying this solution. And while the Russians decided to have a different approach. The Russians actually used a pencil. This gives you a very good idea of what an appropriate technology is. Appropriate technology is something that matches the needs of the user with minimum consumption of resources and avoiding negative impacts on the environment or other dimensions. This brings us to the concept of sustainability. So the concept of sustainability is somehow similar to the one of appropriate technology in the sense that, as it was already introduced by Tobias, it sums up of different dimensions. So sustainability, by definition, means meeting our needs without compromising the needs, the ability of the future generators to meet their needs. And this can only be done when all the different aspects are considered. So not only technical aspects, but also environmental aspects, social aspects, economic aspects, and so on. And this is crucial, especially in a context of international cooperation, where normally you as the, for example, in my case, as the engineer, have a different background compared to the people that, for example, we use the technology. So not necessarily your idea or your objective is actually the one that is needed. Understanding the background and the different dimensions is fundamental to have something that is sustainable and to have something that is appropriate to the context. Focusing more on energy, this brings us to the concept, to the importance of proper energy planning in a multidimensional framework. So, for example, here I've put just for example as an example the framework that I developed during my PhD thesis for energy planning. But the important concept, whatever is the framework that we adopt, is the fact that it must be multidimensional. It's not only about technology and numbers and design, but is also understanding the context, understanding social needs, understanding environmental issues, understanding what is possible to be done under a political way, and so on. So from the small to the bigger, to the broader concept, we end up with the importance of adopting basically an holistic approach. Now, what do I mean with holistic? Aristotle in the Metaphysics wrote, the whole is something besides the parts. And I will continue with the comparison like with the space, focusing on our solar system. So our solar system, you know that it's basically made, composed by the planets and the sun, our star. But now if you go and study one by one the planets and the star, each one alone, you will only get some few informations about the solar system. Why? Because you know that most information about the solar system is about the interactions that we have among the different elements. So it's not only which elements constitute the system, but actually how those elements do interact each other in the system. So having a holistic approach means to study not only the elements, but also the interactions. And this is essential when you want to consider something under sustainability cap, or to understand if technology is appropriate or not. Now, let's put this concept into practice. The case of Laccio Hospital. So Laccio Hospital, where I work since 2 years as a head of technical department, is situated in North Uganda and is the biggest non-governmental hospital of East Africa. And since the 60s has the mission to guarantee affordable medical services to the most needy. Just to give you an example of how the things evolved, this is a picture in the early 60s of the hospital, and this is the hospital today. The main characteristic of this hospital is that it is like a small city. So it's not only the hospital itself, but it also have different structures and functions. Before going through them, let me just give you an idea of the size of the hospital itself. So in 1 year in the hospital, we have on average these numbers. We host around 250,000 patients. We treat actually 250,000 patients. We have 800 and 500 deliveries, more than 5,000 major operations. It's not only an hospital, as I was saying, it's also a training center, because we consider training as a very important element for the sustainability of the system. So we have 200 in normal times. Now, of course, the thing has been disrupted. But in normal times, we had 200 students from the Faculty of Medicine from Gulu University, around 700 students from different kinds of training schools. And the compound also hosts partially some of the staff. We have in total 750 staff, more or less, of which around, I think, 30% live inside the compound with the families and parents, which brings to around roughly a number of around 2,000 people living inside the compound. So as you understand, Laccio Hospital is not only a hospital, it's basically an independent, almost independent city. And this makes it a very interesting case to study sustainability. What adds to this is that all facilities, machines, buildings, all you see has been constructed, installed, and maintained by the technical department with internal resources. So, of course, the hospital has got integrated facilities. Here we have the most interesting for our case. So we can see that power supply, we have the national grid, but we also have backup diesel generators and solar photovoltaic systems. We do have solar systems also for water heating and thermal needs. Then the hospital has got its own water pumping supply and distribution system, and also its own wastewater treatment system, which also includes in the same area an incinerator for the infectious waste. We have a farm that provides food for the school. We have plantations that provide firewood and timbers for construction. And all these systems are managed by the technical department. More in details, So you have understood already that we are talking about a very complex system. And I want to underline some, let's say, seeds of sustainability that we have in the different areas, technical areas. So about electricity, basically Lachor is a mini grid. It's connected to the main grid through an 11 kilovolt line, but also covers around 30% of its needs with electricity produced from solar panels, and this will increase during the years. And diesel generators are supposed to be only a backup. On the part of water, the whole system is managed by Lachor, including the boreholes. We extract around 300 cubic meters of water every day. And we try to reduce the consumption by using as much as possible rainwater. Also in terms of hot water needs, 100% of sanitary hot water and around 70% of hot water required by the laundry service is produced using solar systems. Then waste management, we need a medical incinerator, which maybe is not the most sustainable solution, but the only one appropriate to the context for treating the high infectious waste. And we have a natural wastewater treatment that allows to treat the effluents produced in the whole compound. Last but not least, in terms of environment in general, the hospital has always tried to maintain as much as possible green areas with a large surface, plus has developed the tree plantations to provide, as I said, firewood and timbers for construction. Recently has also started an organic farming project, and we are trying to start a project for plastic recycling, and all the kitchens are provided with improved stoves to reduce the consumption of wood. Now, going back to the concept of appropriate technology, I want to pick specifically the example of cook stoves to ask you something. So now all these three types of technologies for cooking are actually used in the compound of Lachor Hospital in different places. Now, which one is the appropriate one? If you haven't got the concept of appropriate technology, there is no clear answer to this, or at least we don't have enough elements so far to say that. The reality is that the appropriateness of a technology also depends on the culture and education and the capability of the final user. So as you can see on the left side, we have stoves that are used by individual users from the village to prepare meals for the patients. In the center, we have the kitchen that are used for the schools. And on the right side, we have the kitchen that is used in the guest house for international guests. So different users, different people operating the technologies means that you cannot use the same kind of technology, even if the purpose is the same, because their operation depends on the knowledge of the user and on the capability of the user. So in a certain sense, we can say all the three solutions are actually appropriate for the context of Lachor, depending on the user and the area where they are used. Of course, some of them have less or bigger impact on the environment and whatever, but that is not the only dimension that we can consider to make it to actually reach the goal, to satisfy the need of the user. In terms of interlinkages, sustainability, as we said, needs an holistic approach. So here I've reported again the different main, let's say, facilities. So we have solar heating, we have electricity, the production of food, water pumping, and whatever. And I will report as an example some few services, for example, laundry, kitchen, and sterilization, and some areas of the compound. So we have the hospital itself, the residential areas, and the schools. It is important to understand the sustainability to study the interactions that happen among these elements. So, of course, energy, in particular electricity, for example, is needed for all the services and all the areas. But solar heating for heating the water is only mainly needed for laundry and the residential areas. We can see rainwater is mainly used for laundry and sterilization and so on. Then there are also interactions between services and areas. So the laundry is a service that is particularly serving the hospital, while the kitchens, for example, most of them are for the school. And then there are more complex interactions between the different groups. So all the areas in the hospital produce wastewater, and the wastewater, partially, the treated wastewater can be used, for example, as a fertilizer for the farming. This just to give an example of how we consider sustainability interlinkages under an holistic approach. To do the job well and to understand where we are and where we want to go, it is very important to underline, of course, the importance of information and data. Without information and data, you don't know if you are doing well or not, and where are the most important rooms for improvement. So here, just to give you an example, are some screenshots from the control system of Laccio Hospital for what regards electric energy, where we can know how much we are producing from solar systems, what is our load, what is the load of the different departments, and this can teach us, for example, how to better cope loads with consumption and production and so on. To conclude, of course, Laccio is a complex system. It is difficult to say that it is fully sustainable. We try our best, but it's never fully sustainable. So there is always a room for improvement. And here I've put just some ideas. For example, the idea in the future is to focus on better solid waste management, reduction of water consumption and increase of the consumption of rainwater, an increased energy efficiency in terms of coping better the loads with the solar system production, reduction of fossil fuel consumption from the diesel generator, for example, installing batteries, and who knows, many other possible ideas. So thank you very much, and I hope I've somehow given you, raised up a bit the interest about the team.
Thank you very much, Jacopo. Yes, I think you really did an excellent job in covering, taking, let's say, a broad view of what an holistic approach for sustainability is in energy system, and made a very good example in the case you are working on. So I think it's now time to open the session for questions, comments, reactions from the audience. So I'll leave the floor to whoever wants to raise a question. You can speak directly. If there are many people speaking directly at the same time, we will move maybe to the chat.
Well, good evening, everybody. Well, I'll open the ballet for the questions. So thank you for the interventions, and thank you for the engagement of all the organizers. I will directly jump to a very technical, or say engineer philosophical questions to the first presentation, to Tobias. And I'm interested into knowing what the surfaces of agrar areas are able, what quantities are suitable for holding this reactor technology, say, correctly functional in a most efficient way? What are the boundaries, basically? Can we think about expanding the reactors to the compost reactors to very small decentral say installations, or are they also in the upper limit allowable for very big farm productions? What are the extents?
Mm-hmm.
Thank you.
Thank you very much for the question. So in the bigger direction, there are no technical limits. I mean, okay, there are technical, but no, it would be possible. It has mainly some regulation and economic reason why perhaps we are not doing central compost heat recovery systems. And in the smaller, there is some lower limit. So the diameter of the bioreactor should have 3 meters, which is roughly speaking something about 10 tons of biomass, even less, but depends on the density, something like that. But this fact is dependent also from the ambient, because the external influence in the winter goes into approximately 30 centimeters from the surface into the reactor. So if you are in Alaska by minus 50 degrees, the lower limit will be something about 5 to 6 meters diameter. And if we are in Africa, there is no limit, because we have already ambient temperatures which are so high that we don't kill the so-called thermophile bacteria. So actually that's the limit. And 2 small plants are working, very small, but not during the winter. During strong winter, for example, this year we had some strong winter, and we saw very good this influence from the outer temperature in the first 30 centimeters. Yeah, and in the big scale, some different way of heat recovery would be applied, or I mean, it's logic to extract heat not as we do, because you would need extremely high surfaces, heat exchange surfaces, which need to be by stainless steel, some kind of special ligation of stainless steel, which is very expensive. So for that purpose, it's more used some condenser solution. So to extract the water vapor and to take the heat from there. So actually, it's about 60% of the compost heat in general is latent heat, so condensing heat, and about 40% is sensible heat. With our technology, we extract both of them. There are in America there is one company in America which is making big plants, very big, because in America everything needs to be big, and they just yeah, I'm sorry, but it's like that, and they use this technology by taking out heat to the condensed heat. Yeah, I hope I answered somehow your question. So, and by thinking in agriculture, we're saying it depends. We saw that there's a large difference in the forecasts. So mainly the age of the plant has an influence, but even through the different types. So Chardonnay and I don't know, Lambrusco have different masses, and also the position. So it's very difficult to say, but generally we can say about 4 hectares is the minimum which we are doing now. And by increasing technology and by increasing efficiency of the plant, maybe we will be able to go down even more. And that's from technological point of view, and economically, obviously, as bigger it is, especially for the decentralized solutions, it is more economic, because the costs, the investment costs in the construction, the material costs are similar. They are not direct proportional to the potential. So summing up, we tend to make plants of about 5.7 meters diameter, producing something about 40,000 kilowatt hours thermal heat.
That totally answers the question. Thank you.
Other questions or comments? Well, I have a question, mainly for Jacopo, but possibly also Andrea and Tobias may want to comment on that. So I'm quite interested in the international cooperation dimension. So based on your experience, especially about energy, I'm wondering how, I mean, international cooperation is transforming, is changing. And in a reality like the hospital, which is actually a community, a small village that you described where you are working now, it seems to me that the technical capacity, the local technical capacity is quite high. I mean, that's my impression, but you will tell me more. So I'm wondering, what do you think in such a context is the role of international cooperation? I mean, why do we need people from Europe or United States or, let's say, the westernized world to go down and work in international cooperation? And, thinking about the experience of Andrea, I suspect the situation is different because even within the same country, the local technical capacity and availability of resources for technical staff may be more limited. But yeah, I just wanted to open a discussion on that, maybe starting from Jacopo, but if Andrea, Tobias have also comments, that would be nice, and also from the audience, of course.
Guido, thank you very much. That's a great question. And allow me to share my screen again, because actually, of course, I had to cut my presentation a lot. I had many things that I wanted to say at the beginning, but I mean, it's always like that. You start big and then you cut. But there is a slide that I think is very, I mean, it's really focused on this. So I had to skip this slide, which I like very much to define international cooperation with this phrase from Bruno Rankin: faire, savoir, savoir-faire, faire savoir. So to do, to know how to do, to let others know how to do. So I think Lachor is where it is now today, because this concept has actually really developed in a very good manner, because for historical reasons, for many reasons. But basically, from the 60s to today, it has really been probably sharing between different cultures, different contexts. And this also brought a very wide capacity in all the different aspects. But to focus more about the energy or technical aspects, the action of, I mean, I think in this case, cooperation really has been represented in its most important and core value. It is about sharing. So who comes from abroad brings something that maybe is not known locally, and who comes locally gets something from the context that brings home once leaves and comes back, for example, to Europe or to the US or whatever. So for historical reasons and whatever, of course, we know that basically the technical background is normally more strong from for people in Europe or in the US. I think in the context of Lachar, people have been really good in this action of sharing the technical knowledge. And in the other sense, I think Lachar has given a lot to, let's say, foreign people that have been transiting for long or short periods in that context. And has given a lot about culture, has given a lot about looking at a different perspective or from another point of view, has given a lot as a community. Basically, I think we may say that Lachar Hospital is actually an international community, even in this moment when, because of COVID and other reasons, we don't have many international visitors. But Lachar is also in Europe, is also in the US, is also in all the countries from which has received visitors, because a piece of them has remained here and a piece of Lachar is staying with them. Okay, this was the philosophical answer. Then more technically, most of the technicians that work at Lachar have received intensive trainings also in Europe. Some of them have visited Italy, Austria, and other countries. In this precise moment, we have a technician from Austria, from our technical partner, that is called BBM, and is here with us to teach us how to improve our system. We are working on the system, on the control system that automatically switches between the generator, the solar system, and the grid. So basically, it's all about identifying the value that each people and each country can bring, and getting the best from each side. Getting the best from the technicians that come from Europe, getting the best from the physicians that come from another part, and getting the best from Ugandans about, for example, what they really need and the way we implement things and the way we manage things, because it is very important to underline that Lachar Hospital has a management that is fully I mean, it's completely Ugandan. All the directors are from Uganda, and most of the management system is constituted by Ugandan people, which of course set which are the priorities from their point of view.
Thank you, Jacopo.
Yeah, can I continue? Because I totally agree with Jacopo. Just wanted to add that, yeah, also my experience doing international cooperation, as you said, so as sharing, is of course maybe more difficult because it is slower, and you have maybe to agree on how to do things, and you can say, yeah, you really can. There is the risk to slow down things, but both in international cooperation between European partners, but mostly on developing countries. I've seen that that is really the only way, because maybe I have passion to go on mountains, and you can always say that if you go slow, you can go far. And I think that is probably the topic. For example, so in the project of Tanzania, maybe one could go there and build a super power plant with the best available technologies. But then if people don't feel that as their own plant, the project will fail. Because I think that in that case, really the sharing of also the feeling of ownership on the things, on the projects, is key to sustainability from the social point of view.
Thank you, Andrea.
Maybe I would also like to add just 2 words, an aspect, an experience which I had less now by BioHeat or biologic system, but by my work in Kenya. What I've seen there, it was very interesting, the fact who is the international partner and which interest that he had. And we had really a situation which was shocking from my point of view with the German embassy, where they had some problems with some kind of technologies, but from the general point of view. And this is something which also need to be taken in account when you start a collaboration with who are you sitting on the desk. So why is he doing? Because many are not just seeing it as a help effort or something. They have always an interest. And in our example, we were developing a biogas power plant, and we asked them for foundings, but this was like a very rural approach, simple approach, because we recognized it might be difficult to have some high technology machines and motors and then changing parts. So we tried to work everything with tractors. And the answer of the function guy in the embassy was he would do that if we use some German biogas power plant builder. So, and this was an experience which was not so nice, but maybe it's better now. It's 5 years ago.
Thank you, Tobias. Well, actually, difficult situations are important to be shared because this can happen, of course. And so I'm asking if there is any other comment or question in this debate for the speakers.
Maybe I do have a question for Andrea. Since you have worked on the specific sector of hydropower in both Tanzania and Trentino, in terms of okay, I have actually two aspects that I'm interested to understand. First, in terms of power demand and like load curve, do you think that there is a big difference determined by the behavior of the different people in how I mean to build up the load curve, for example? Apart, of course, I mean, we are probably talking about plants of very big size, of very big difference in terms of size. But in terms of general load curve, do you think that is there a clear influence of the culture of the different behavior of people to generate this curve?
Okay, thank you.
The second one is instead in terms of operation of the plant, at which level you can actually apply similar ways of operation and control in the two different contexts?
Okay, thank you very much for the question. Actually, I think that the answer is probably the same. I mean, Tanzania, the off-grid system was, of course, a small reality, but the physical and maybe social system that drives the behavior of the grid are the same that in Europe. So it was also a good occasion in Tanzania to see these drivers. This phenomena, also physical phenomena, like I was talking before, the regulation of the grid, to see the phenomena like in small, and so they were like extremized. And going back to Europe to see them at a scale which is thousands of times bigger, considering the whole European grid, but the phenomena at the base was the same. I mean, for example, for the load curve, you said, I think that there is a component which is the same in Europe and in Tanzania, which is, for example, the domestic use, because at the end, everyone needs to switch on the light when the sun goes down and to use some appliances where they are at home. I think that we can say the curve for the domestic use, I studied them when I was working for the project, and they are not so different from ours. Of course, we have a more intensive use, but the profile is not so different. There is difference in the, you can say, industrial use, of course, because well, if you are in a off-grid system, maybe you can see also the impact of switching on one single electrical motor. While of course in the continental Europe you don't see it, but yeah, that was the main difference, the use of industrial electricity. And so also the other question was that yeah, so you have the same also for operation it was the same, the technical part, even if it is adjusted for the aggregate technology, as we saw also from your presentation, but at the end it is also the same, because also from the operational part of the plant is that the same technology.
Thank you. Let me comment. You have said something that called, I think, a very interesting concept that I think is worth to be underlined in this framework, because we are focusing basically on sustainability. So let me comment on the fact that I'm always really super surprised about, for example, the case of Lachor, or how good is Lachor in the efficiency it utilizes energy, for example. Because if you think that this is an hospital that basically sees a presence of around 300 people every day and more than 600 patients, and our peak is only less than 250 kilowatts. So this means that basically the same energy, I said we consume annually around 1 million kilowatt hours. That may seem a very big amount, but it's actually what corresponds to an average consumption of around maybe 300 houses in Italy. So with the consumption of 300 houses, we are actually able to treat 250,000 patients per year and to supply around 2,000 people per day. Of course, maybe with an effectiveness that is a bit lower than European standards, but the efficiency is incredibly higher than European standards, or of course even more for American standards compared to the results.
Yeah, really. I would really like to underline that what probably you have already done in Lacor is probably the target configuration of an energy system which is sustainable. I think that our energy transition, which is ongoing here in the Europe, is pointing to something like you already have. Because yeah, also my presentation I skipped, but there was the part of the distributed generation. You know, now it is when we talk about distributed generation, we mean small generators instead of few big power plants. You have maybe small generators which also the consumers can install on their own, becoming prosumers, so producer and consumer. And this is of course not just about the technical part. It is more about consciousness, I think. And I think maybe what they have in Lacor maybe is the conscious that if they are producing the electricity, maybe they know that maybe during the daylight hours they have more sun, so maybe they can wait to use that appliance maybe when there's the sun. Or also I think maybe there's higher attention in that context that maybe we can have in our home when we don't have the feeling of what is behind that electric also in the switch of the light. You don't have the feeling of what is behind that. Maybe, I don't know, just correct me if I'm wrong.
Interesting. I don't know actually, but it's an interesting comment actually.
Yeah, also I had a question for you, because I saw from your presentation that you have also diesel generators with 15% of production. Did I read correctly? Because I was wondering if that means that you have power shortages requiring diesel generation for 15% of the use, which is really high.
Yes, actually, at the moment it's higher than that.
Really?
Our solar system is cannot work without a grid. So it means that, and we don't have a storage. And so that's why I commented storage could be one of the future elements. So at the moment, we only produce solar energy when we are connected either to the grid or we run the generator. So as I said, more or less, the 50%, and in this particular moment, they are making some improvement on the grid, but basically the effect is the opposite, because we have a lot of shortcuts due to the work they are doing. And in any case, the unreliability of the grid here in North Uganda is unbelievable. I would say that on average, we have power maybe maximum 60 to 70% of the time. We can have several blackouts. Today we had, I think, 6-7 blackouts. We can have short blackouts. We can have blackouts that can, last year we had a blackout for 1 week. So yes, that explains those figures. And unfortunately, I think this year maybe they may be a bit worse.
Thank you. Just talking about the quality of the access. Yeah.
Yeah, the quality is terrible, and okay, I don't want to go into too technical things, but voltage, if you look at the voltage or the flickers, it's something that is just unbelievable in an European context.
Yeah, also endangering also the users, which can be subjected to.
Yeah, we have many fault. We have different protection devices that somehow like protect the system from the outside situation, but still we have many faults that are due to voltage spikes and things like that.
Thank you very much.
Welcome.
Thank you. It was quite interesting also, I think, to realize coming back to the concept that Jacopo was mentioning about international cooperation is about sharing and learning that we have a lot to learn from how with like a small amount of energy we can feed quite a large system. I think is a nice example of mutual opportunity to learn from each other.
Yeah, definitely. To me, also, for example, this system can teach you things that you cannot learn in Europe, because, for example, spikes or voltage anomalies and these kind of things, we are not used to those, and we don't know what they can cause, and we don't know how to cope with them, simply because we don't have them. So for especially for someone that is developing its knowledge about electric system or whatever, it can be a very interesting school.
Okay. I think we are coming close to the end, but I'm wondering if there is anyone in the audience who has a question or comment.
I just have another funny question regarding the flag of ESIC. Is it necessary to be curious and to handle about such concrete application of say international cooperation? Is it necessary then, if we want to seek out such amazing goals that we had the pleasure to listen to tonight? Yeah, is it necessary then to look at the world from upside down, like is drawn on your map behind your head? Is it a necessary say set of mind in order to achieve such great work? And yeah, I've had also regarding the question on international cooperation. Other feedbacks. I've been in a German university that does the student organization with graduate students and pre-graduate students. That is the Engineers Without Borders. and I've had some feedbacks from those students which were not at all satisfied, say, upon the diplomatic relations installed in the country they were implemented to. So yeah, is it a task that we have to especially respect, to see really the ups and the downs of the world in order to even think about implementing some technical solutions elsewhere? And to what degree do we have to apprehend this aspect?
Thanks for the very stimulating question, Pascal. Let the speaker, if you want to start putting some comments.
Well, briefly, I think the answer is yes. Definitely, we do have to look at the world upside down, but not only. Let's look at it also from each corner and maybe also from the other side. But this is not only because we are talking about international cooperation or the global south or whatever. This is something that I would actually recommend you to do in any kind of context and whatever you are doing. Because especially, I mean, it is valid for, I think, any kind of profession, but for example, also in the engineering field, most of the times a new solution, the right solution, comes from an idea that you didn't consider before because you didn't look at the problem in the right way. Many times when you're stuck, you don't find the solution, is because you're not considering the right perspective. And that is not only about cooperation, but I mean, it is about cooperation in the sense that working in a cooperation context helps you to have different perspectives, because you can actually talk with people that have a different view. And so maybe you can reach a solution that you wouldn't have imagined by yourself. But even when you are alone, it is always important to look at the problem from different perspectives. That's my idea.
I think the anecdote of the space pen and the pencil is a nice example of taking different perspectives.
Exactly. Exactly.
What I would like to add is that when we speak about cooperation or simple cooperation without international, then it's a matter of relations. And this relations taking multiple viewpoints, upside down, side, corner, other dimensions, it's very important to consider the system and not only the components, basically.
Yeah. And sometimes we are actually stuck with what we have studied or with our background, and this is actually the main point that like prevents us to see a solution that maybe is in front of our eyes, but only that we cannot think it in the right perspective.
Last questions?
If I can intervene, Guido, I would like to put a question about the energy poverty that is concerning not only Africa or Latin America, but even Europe, because there's lots of energy poors. And this is the change of perspective we have to do, even in university, teaching international cooperation. That is a behavior, not only a specific discipline to study. My question is, what about the community-based energy production and consumption model recently launched by the European Commission in Europe as a strategy to combat poverty and energy poverty even in Africa, and especially in the experience of Jacopo? What about it? Thanks.
Maybe Andrea can also comment on that. I guess. In general, let me say that I do absolutely agree with the idea of changing a bit perspective. Also, I mean, one error that I think we always make when we talk about cooperation contest is like to put the line, no? You know, there is the South and the North, or the Europe and Africa, but it's an error that we also make even for Africa. Like many times when we talk about cooperation in Africa, we say Africa, but Africa is actually a continent. What is Africa? It's like I always think like as someone that wants to travel to, I don't know, from the US